Okay, ladies and gentlemen, a very warm welcome to the webinar, Enterprise Blockchain in the New Decade, proudly brought to you by the Blockchain Association Singapore, or BAS. Before we dive into the webinar, please allow me to take a few moments to share with you today's program and what to expect. So first up, we'll be starting with a welcome address by Ms. Tan co-chairwoman of BAS, followed by a presentation of the key findings from the joint research between OneConnect Financial Technology and the Singapore Management University on the potential of quantum computing in augmenting blockchain. The research report has been vetted by BAS, and the key findings will be presented to you by Associate Professor Paul Griffin, School of Computing and Information System, SMU, after which we'll have an exciting panel discussion where the blockchain experts will take us through whether blockchain, enterprise blockchain will take off in the new decade. So stay tuned. We also like to bring to your attention that we have set aside 5 minutes for Q&A at the end of the event. So please send us your question in the Q&A function, and we'll try our best to take in your questions as far as time permits. So without further ado, it's my pleasure to invite Ms. Tan Bin Ru, co-chairwoman of BAS, to give us a warm welcome address. Ms. Tan, please.
Thank you. Thanks, Alicia. Welcome everybody to the session. Let's just dive in. I wanted to first introduce as a sponsor of the event, just very quickly, OneConnect. We're the fintech arm of China Ping An, listed in New York. Our focus is on digital banking solutions. And you can see that in China, we service a lot of banks already and insurance companies, and overseas, we service more than 100 clients currently. On the map there is Southeast Asia. Singapore is the HQ. So we're largely expanding in Southeast Asia currently. So this is the very, very brief, short intro. I wanted to, before the session begins, to really introduce Blockchain Association Singapore. I think for last year, we had a couple of events. This is maybe the second event of this year. So very proud that it's going to be done together with SMU. For the Blockchain Association, since it's only set up last year, it has largely grown. We look at fostering the blockchain ecosystem in Singapore and really inculcating communication, collaboration, and using blockchain together with other scalable technologies. Very quickly, over the last short 18 months, our membership has grown to about 70 from a mere 20 or 30 members. So it's growing very fast, the blockchain community of Singapore. Here's a bit of the membership details. There are corporate memberships as well as individual memberships. Please feel free to join us. You can see the link there. There is also a LinkedIn page, Facebook page for you to go to. All right, so that's a brief introduction of the event. We have a lot to expect. So I'll pass the time to Prof. Paul to go through the research between OneConnect and SMU on blockchain and quantum computing. Prof. Paul?
Okay, thank you very much. Thanks for the introduction. I think you have to stop sharing your screen. I can share the slides. Thank you. Okay. So hopefully everyone can see the slide. First of all, I'd like to thank Blockchain Association of Singapore for giving this opportunity to talk about this research. And of course, thank OneConnect for the funding and also for all the support and the people involved in this project. So what I'm going to talk about is a brief research overview, what we was trying to do, the problem we kind of was trying to look at, explore, maybe not solve, but explore, the approach we use. Touch on quantum computing. I know a lot of people have probably heard of quantum computing but may not know much about it, what we did, what our results were, and then a conclusion, further work. So the project started 1st of February last year. It was a one-year project. We really wanted to take this idea of quantum computing, which is, I mean, the theory has been around for many years, but it's only in the last few years that quantum computers have become real and you can actually use them to try things out. So we thought, let's have a look at applying this to DLTs, to blockchains, and see what we can do, what quantum technologies could do or can do with blockchains. And looking around, we thought, well, let's go to the sort of fundamental level of the blockchain trilemma. This has been talked about particularly in the, Vitalik Buterin, the inventor of Ethereum, came up with this term. I think it's quite a nice idea. It's quite kind of fundamental that it's very difficult, or if not impossible, to increase the size of your consensus network, so how many nodes you have, and increase the speed of that consensus network, and maintain or increase the security of your network all at the same time. There's always got to be some kind of compromise between those three. So with a classical network, we can see that the public blockchains have proof of work, which is a very secure method. You expect that there's going to be lots of attacks on the network, and so there's a very secure ways to maintain consensus like proof of work. In a enterprise blockchain, which we'll be focusing more on, that sort of condition of maintain that security can be relaxed because you have players, and so we can use a faster consensus and still maintain larger networks within the consensus, and so this kind of security is reduced. So those three different properties have to be played around with. So thinking, can we look at quantum technologies to see if we can break through that and maintain, maybe go to a different level? So looking at generally what quantum computing can do, we can increase data sizes massively using the quantum idea of superposition. And we can also improve security with quantum entanglement. I'll mention those a bit more later. But the speed side of consensus hasn't really been investigated in much detail. There's a few research papers proposing a few ideas, but we thought we'd have a proof of concept to try these things out. So just a quick update on quantum, just to fill in some of the gaps maybe. So first of all, the promise. So the main promise of quantum computing is the potentially enormous processing power which quantum computers have. With a classical CPU, central processing unit, you're always going to process one value at a time. Even with a 64-bit computer, you're still processing a 64-bit value at any one time. But with a quantum computer, with n number of qubits, you can actually process 2 to the n values at the same time. So this gives us a potential huge kind of parallel processing type idea to be able to store and process a large amount of data at any one time. So with 100 qubits, and we're getting close to that now with the real machines, you can process 1.3 times 10 to the 30 values. So that's an enormous amount of data which can be kind of simultaneously acted on at any particular point in time when you're processing it. So what this means in kind of real terms is that here's a kind of a graph of Fourier transform. I guess if you're coming, probably you've heard of Fourier transforms in signal processing, where you take a wave and you find out the frequency. So the blue line here is a classical fast Fourier transform algorithm. And if these are kind of bits or number of bits, it starts to slow down quite significantly after we get up to about 2023, whereas a quantum Fourier transform is slower at the beginning, but then as the number of qubits, as the amount of data we're trying to push through this algorithm increases, the time it takes to run the algorithm becomes much less. It still increases, but much less than the exponential increase in time for the classical Fourier transform. So that kind of gives you a flavor of why we're looking at quantum computers and why also we need to have better quantum computers as well. On the security side, with quantum cryptography, we've got communications now over 1,000 kilometers, still really experimental. It's there's some banks starting to look at this in production, so it's kind of starting to get there. There's also satellite links now using quantum entanglement and cryptography. Quantum computers, you may have heard last year, Google claimed to have achieved quantum supremacy by running an algorithm that would take a normal computer 10,000 years, although, and the quantum took 200 seconds. That's a huge difference. Although IBM did say they could do the same algorithm and tweak up one of their supercomputers to do it in 3 days. So that's really the difference between quantum supremacy, which means quantum computers can do something which classical can't, compared to quantum advantage, which means that quantum computers can do things better than classical. So I think that's quite interesting. But really, one of the main differences really is if you have a deterministic calculation like 1 + 1 must equal 2, classical is the best way to go. But if you have a probabilistic calculation, you're trying to optimize something, you're trying to work with probabilities, then quantum computers is very native to do that. So you can look to them to improve those types of areas. Consensus is a non-deterministic mechanism, so it's a kind of a good fit in theory. Other applications, credit scoring, portfolio analysis, market forecasting, finance, arbitrage. There's a lot of different areas now that people are looking at quantum computing to see if we can get improvements. So coming back to this research, we wanted to develop a real proof of concept for a quantum distributed ledger. It's a very ambitious approach, and we kind of only got part of the way, but we also wanted to uncover potential advantages by doing this as well. So we connected up with IBM, the IBM Q network, and we're very thankful for them. They gave us access to their simulators and their real backends. We decided to go for a leaderless consensus protocol and focus in on the consensus mechanism itself, taking a classical Ben or FLP type of consensus and creating a quantum version of that. We developed a full kind of POC framework in Python, where we could run this different algorithms and different network topologies on quantum simulators and backends, and compared that to a classical consensus, which we use a disrupt package, which seemed to behave quite nicely. And out of this, we're also currently applying for a patent for the quantum algorithm. So what did we do? We started off with 3 nodes. Let's not be too ambitious. So we have 3 nodes. This is a diagram showing our blue circles are 3 nodes, 0, 1, and 2. Then we connected up with in this showing a unidirectional network. This is all run on one machine because we don't yet have quantum networks connected up to quantum computers. We have quantum computers, we have quantum networks, but at the moment there's no technology to effectively and efficiently join them together. So we ran on one quantum computer. We looked at then expanding this up to be 10 nodes to see how the agreement consensus worked as we moved from 3 nodes up to 10 nodes. And we also tried a few different topologies. So this is a what we call a partial ring. We also tried a partial mesh and tried to make it kind of more difficult for consensus and see how quantum compared to the classical. I also looked at looking at the variation in agreements across the network and within the nodes themselves. Digging into the nodes, this is kind of a bit more detail. So each of those nodes, we saw the blue circles comprises of a classical computer, because we're always going to have classical computers to communicate with quantum computers. We live in a classical world, we have real numbers, so we have to interface, send data to the quantum computers, let them do their thing, and then get the classical data back into quantum data, turn that back into classical data to be able to process it. And then we had sort of software connections between these 3 nodes. So get on to the results. With our simple 3-node ring topology, we saw a nice convergence. We did try bidirectional ring first of all, but that converged very quickly, so it's a bit boring. We want to make it a bit harder. So our unidirectional ring converged quite nicely after about 6 rounds of agreement. So this is the value of the node means, an arithmetic mean across the values within each node, and you can see that they're converging to the mean of the network over 6 rounds. We had a threshold to stop the algorithm after a certain variation, sort of a maximum variation. And we can see here even that the variance between the nodes is going quite quickly down to agreement levels. So we got 100% agreement within the threshold after 6 rounds. So that's quite a nice result. We thought we'd then try and take it onto a real backend. So this first graph on the left is our same as before, so the simulator. And then we put it onto real backend with the same initial starting points. And the good news is that it did reach a convergence. It did agree. The bad news is that the noise meant that the value it agreed on wasn't the correct one. So we know what the network is supposed to agree on, and the values generally kind of sank due to the noise in the qubits itself and the readout noise. So we thought, what can we do? So we looked at the error mitigation packages which IBM have, and we deployed one of those and got the consensus back up to a similar value which we received with the simulator. But the problem there, really, we have to calibrate the quantum backends quite regularly. So we will need to have better quantum machines in the future before this would become even kind of worth developing in production. So we can see that, yes, the real backends do still agree, but we do need to either get better qubits or better noise mitigation. So then we took our nodes and increased the number of nodes up to 10. We tried to increase it further, but we have problems then with how long it takes to actually reach agreement. The time it takes to send data to the quantum computer at the moment and get it back, that interface takes time. So we had values up to 10 here. And we also then compared it to the classical consensus as well. So on the right side, the graph B is the classical, again, running on one machine. So it becomes very kind of stable and easy because we don't have the network in there. So that's kind of a sort of linear increase at this stage, whereas and the quantum had a very similar behavior as well. So it's at this point in time we can see that the quantum and the classical is doing quite well. So with increasing size, we should be able to still get consensus. But the one main difference between the classical and the quantum is that the classical on one machine gives the same number of rounds to agree each time, whereas on the quantum side, we see a variation. This is kind of expected as qubits are probabilistic and we are going into that kind of non-deterministic realm. First of all, it's quite interesting that the arithmetic mean is not the same as the mode. So if we take the mode average, that's much closer actually to the classical. So that's the total number, or the greater amount of rounds as opposed to the average across the whole set. We can certainly see there's a skewed distribution here. It's not normal. If it was normal, the mode and the median and the mean would all be the same. So we do have something skewed, and it's sort of skewed with more in the same or less. So it's quite interesting that this gives the idea that there could be potentially an advantage by engineering the network to favor the shorter agreements could potentially give us a faster agreement. I'm not saying that's kind of guaranteed, but because we have a variation and the variation is not just longer, it's also shorter, then that gives that potential. So yes, that's the interesting part there. So really overall, we can see that I think from these experiments that at least, I mean, first of all, quantum consensus works. That's the first good thing. We can then compare it to the classical and see that the behavior is very similar, which wouldn't really be, I think probably that surprising considering that we're just moving information around these networks, and information theory will be the same whether it's quantum or classical. The data itself is different, but the lump of information will be the same. Quantum consensus does have more variation in the number of rounds. It can take longer or it can take shorter. So I think that also gives a indication of something interesting to investigate further. And also the current state of real computers is, as we kind of might expect as well, not up to the standard that running these algorithms, we need to have better qubits and better noise mitigation. So I think as a conclusion, we can say that our quantum consensus has similar behavior as classical. So that kind of implies that our scaling of data should be achievable. So given that our qubits work in a similar way to our bits in classical and give us this consensus that we're looking for, we should be able to now scale up the amount of data that we have in our consensus. So for example, if you wanted to do consensus using big data rather than just a few hundred transactions, for example, now we could potentially have this kind of big data being in consensus throughout the network. The consensus has more variation, offering the potential for faster agreement if we can understand where this variation comes in and how to potentially tune our qubits to be faster. So I think the speed of consensus is similar as well, as we saw with the graph of the sort of time complexity as we increase the number of nodes. So I think there is a good chance that we could break, or at least move the blockchain trilemma to a whole new level once we have good quantum computers and once we have the network giving us a quantum internet. So there's a lot of further work to do, as you might imagine. There's obviously work in the quantum technologies themselves, but using quantum computing, and particularly for DLT, we can look at a fully quantum consensus algorithm. The consensus algorithm we was using was a kind of hybrid between the classical and the quantum. We could make that fully quantum. We'd also explore other types of consensus. Most common in blockchain at the moment is sort of elected leader, where instead of agreeing on a value between the nodes, one of the nodes is given the opportunity to be the source of truth for that particular round. The other nodes will validate, but that one node is elected to be the leader, at least for that one round. We can apply what we have, I think, at the moment to other issues like the oracle problem. So oracles do need this agreement in consensus, and to see what the variance is of the nodes to be able to agree on the value to be used for your oracle data point. We could also use this technology for other types of decentralized applications, such as autonomous agents. If we have quantum data, that takes away the problem of converting classical into quantum. So like light sensors, connected up IoT devices, connected up directly with quantum computers over quantum networks, will enable this to work a lot better, a lot faster, and explore all the various quantum internet applications that are now starting to be discussed in the community. Of course, quantum computers have many applications in financial analysis, machine learning, optimization, etc. And there's also many other blockchain projects where this could also potentially be used in the future as well, such as blockchain interoperability. There are various security mechanisms for helping your security and enabling data across different blockchains as well. So I think it's a very interesting and fascinating area, and there's a huge future for it. Okay, so that's it. It's a very kind of whirlwind approach, and I hope that was interesting for everybody. Thank you very much.
Thank you, Professor Paul, for the insightful sharing. Yeah, it has been a year since OneConnect and SMU worked on this research on using quantum computing to enhance the blockchain technology for businesses. And I think there's a lot of interesting things that can happen with this research, although it's a small breakthrough at the beginning, but very good findings. You can imagine, I think Prof shared earlier, what can be done in 1,000 years or 10,000 years can be done in 200 seconds. I can imagine for algorithm optimization, for financial analysis, for big data analysis, that should drive a breakthrough. We have an exciting panel to further bring this to a discussion. Let me invite the panels to switch on their cameras. Then I can introduce the panels. We have Peter, who's the global sales leader from IBM Systems Digital Assets. And then we have Amit, who is the head of Asia Pacific from R3. Then, of course, we have Prof. Paul, associate professor for School of Computing and Information Systems from SMU. And then lastly, we have Dr. Ernie Teo, who is the co-founder of Decodo, vice chairman as well for Blockchain Association Singapore. And before we start, I forgot to mention that the research between OneConnect and SMU is also vetted by Dr. Ernie Teo for representing the Blockchain Association Singapore. Okay, now we have a nice panel. Let's maybe start. You've heard the research of Professor Paul. And then maybe let's start with a short intro of your company, what you do in the blockchain space, and maybe any use case, inciting use case to share. Should we maybe start with Amit?
Yeah, good morning and great to be here. So very excited about the research which Paul and you guys have done as well. So super cool. A quick intro on R3. We are an enterprise software company. We were founded 6 years ago, currently with 15 offices, around 400 people around the globe. Our mission in life is to build enterprise-grade software for multi-party business problems. Most people know us for our flagship distributed ledger platform called Corda. Corda now has over 400 customers and partners globally, and scaling rapidly. But most recently, we also have announced a new product on multi-party confidential computing, and the product's called Conclave, and this is built in collaboration with Intel. So a lot going on at our side. And Conclave empowers businesses to develop applications that analyze the data and process the sensitive data from multiple parties while ensuring confidentiality. So essentially, I think we are seeing more and more applications where multi-parties are coming together, right? So that's really what we do as a company. Going to your question, Ms. Tan, two quick use cases of what is exciting. One is an industry consortia use case, an example from Italy, where 100+ banks in Italy are now using a platform built on Corda to do interbank reconciliation. Over 350 million transactions processed in the last 6 months. It's a huge scale, right? And a real classical example of where blockchain platforms and Corda can be used. And the other one more closer in the region in Thailand, and a slightly different use case and a slightly different ecosystem, where in the trade and supply chain space, Siam Commercial Bank and Siam Cement Group started off building an invoice procure to pay solution that now has scaled from Siam Cement Group to over 70 other corporates and 6,500 suppliers. So, to this panel topic, which is about what's the future of enterprise blockchain, I think these are good examples to illustrate where we are headed.
Fantastic. It's really good achievement to see that such skills is already happening, right? Both in your Corda as well as your 100 banks and your CM Cement Group. Should we move on? Just based on how I'm seeing, maybe move on to Ernie, then we'll go to Peter. Yeah. Ernie, you're on mute.
Hi everyone, I'm Ernie. So I guess I represent more of the startup space in this panel right now. So my company, Didoco, we are about a year old only. And we are working in the space of enterprise usage of and using blockchain as a technology as well. So Didoco basically is a decentralized document connector. What it does is it's a document process management platform. We tap onto blockchain to kind of provide for the concept of to realize the concept of a verifiable document or verifiable credentials issued by various different companies. The platform is a SaaS platform. Basically, it allows our users to tap onto to blockchain technology without being involved in any consortia or being involved in any being directly involved in any blockchain network. It's basically a tool for them to utilize our the processes that we have built for them, such that whatever documents that they send out, say for signing or that they issue out of their company, can be verifiable via blockchain, basically, right? So we are very open to working with various different partners. So more recently in November, we have integrated with Sign with SingPass here in Singapore. Which means our platform allows for CA type signing as well, that then we record on blockchain as well, to provide kind of evidence and proof beyond the PDF document. We are also integrated that with some local partners here, for example, ERA Property. So they are using our platform to actually kind of sign tenancy agreements right now via our platform. Right, so for us, the use of blockchain is really as an underlying technology. We don't really kind of sell it as the that we are a blockchain business or anything like that. But I think that's the way going forward for a lot of the enterprise tool space, where blockchain may be a part of the solution that provides more transparency, immutability, and the verifiability, which I think now is a trend going. I think Peter will talk a bit about the health pass stuff as well, right? And that I think will be the space going forward. Yeah.
Fantastic. I'm in the midst of selling my property. I'm going to tell ERA that I will insist that my transfer of property title happens on blockchain. How about Peter?
Maybe you should make an NFT out of your property. Everybody else is. I think we got two great concepts here. We have, enterprise blockchain, and then we also introduce this notion of verifiable credentials. And, heretofore, and I think Ernie could really talk to this as well, but, self-sovereign identity concepts have been around for a long time, and we really haven't seen them take off. But because of COVID-19 and because of, folks like Ernie, who can basically take on DocuSign with blockchain, okay, we can start to bring together these concepts of self-sovereign identity and combining those with blockchain and basically putting it all in the back end, if you will, the backdrop. I agree that, today, we don't sell enterprise blockchain. We sell actually usable solutions, right? And I know that Amit has got a whole host of them. And at IBM, of course, we open sourced Hyperledger Fabric back in 2016. So we've been in this space for quite some time. And in fact, invented a lot of technologies along the way. If we think about, just take a step back, where's the action, right? Well, PwC recently did a survey about 60% of CEOs out there of major corporations, and they came back with basically five use cases, if you will. As not surprising, product tracking and tracing, it's to the tune of $960 billion market, right? Financial services and payments, about $400 billion. Again, identity, security, and credentials, $224 billion, right? Contracts, dispute resolution, loyalty and reward programs, rounding it all out for another 100 billion or so. What is enterprise blockchain though? What is it, right? And we think of it, and I think Amit would see the same. Enterprise blockchain is essentially a permissioned network or ecosystem, right? That provides a consensus between semi-trusted participants in a way that you can have high performance and scale, because it resolves the identity problem, right? Everybody on a permission network, is a known entity. They might not trust each other, okay? But maybe they've all been KYC'd. All the transactions have, passed AML checks. You just don't have to build for all that stuff. And I think this is kind of where, enterprise blockchain has really had an early start, is because we can kind of take some of these tricky things off the table, and they are tricky for public blockchains, right? And it's one of the reasons why self-sovereign identity, in the case of Sovereign Network, never really took off. But again, as we're starting to see things, they're starting to come back, right? So let's talk a little bit about one example. And I think that, Ernie teed it up earlier. And since, COVID, I mean, how many people have one of these? This is my safe entry app. I think, well, everybody in this call has one, right? Now, if you're in New York City, okay, and you want to go to a basketball game or to Yankee Stadium, and they've recently allowed 20% of fans to attend these games, right? If I showed them my safe entry with my Moderna vaccine, thank you very much, Singapore, for allowing me to have that, by the way. But you think they would say, yep, that's good. We accept that. Yep, we believe this safe entry app from Singapore, no problem. Okay, or if you're in the US, there's no sort of 17 other health pass kinds of initiatives, right? Well, chances are you're not going to really buy in, right? You need to get this trust. The trust here is decentralized. It needs to be decentralized. It can't be centralized. So if I'm in New York, I'm not going to necessarily believe a platform from California, okay, or vice versa, right? So you need to have some kind of arbiter of truth that everybody can kind of build on top of, right? And so we've at IBM have come up with something called the Digital Health Pass solution. Again, this is a fabric-based thing, and the idea here is really to enable the secure verification of credentials, right? There's test results, there's vaccination records, but there's no need to share the underlying medical and personal information. In fact, the apps don't even collect it at all. And in the case of New York, the app is called Excelsior Pass. And you can even use a QR code on a piece of paper to make it work, right? So it's super easy. All you have to do is, there's 3 steps. There's an issuing organization that generates a verifiable credential, okay, sends it to the individual. Let's say it's me, and then I go ahead and I load it into my phone, okay, and then I can share it with a verifying organization, and they go, yep, that works, right? Because they can validate it on a blockchain. Blockchain is not mentioned anywhere in this, okay? This is all about me going to a baseball game, right? That's all I care about. And hopefully, and as things open up around the world, these kinds of applications will have greater utility to create a more 2019 feel to life, because right now, honestly, it doesn't feel like that, right? And so anything we can do to kind of benefit from that, I think is a good thing, right? And, in terms of IBM, we've got several large production consortia recently teamed up with Moderna, by the way, to do vaccine management. We have Food Trust, TradeLens for supply chain finance. And what was interesting, and I think Amit has the same with R3, is that if you're a concrete business in Thailand, okay, like Siam Cement, right? And you want to do bank guarantees, loan guarantees or whatever, you can basically interface, with what I think it's not called Voltron anymore, is it? Contour. And or you could do the same thing on the IBM solution. So these consortia then sort of become their own companies, right? Their own P&Ls, their own companies separate. So it's like they're being born from so Contour was born from R3, right? And it's its own entity. Okay. And so now if you're Siam Cement, you have choice. You can go ahead and reduce the friction by choosing which of these different blockchain consortia you want to deal with. And it's just an API away, right? So this is kind of some of the reduction in overall friction and cost and increasing participation that the enterprise blockchains provide you and have provided you. But I have to tell you that enterprise blockchains take a bad rap from the public blockchain world, right? And in my job, quite frankly, whilst I am responsible in IBM to secure these enterprise networks with our technology, our focus is 100% public chain, right? And so the question back to this panel is, is there a place for the public chain to sort of, take on some of these capabilities that we've already seen in the enterprise chain, and maybe that becomes the future of the enterprise chain, where it's not either or, it's actually probably both with some interoperability, right? I mean, look what's going on with respect to R3. They have, they're building multi-party computation stuff. They're building interoperability with other chains. We are bidding on projects with Corda on the back end, and then DAML on top for all the smart contracts. So there's no vendor lock-in, if you will. And then of course we have R3, we have Quorum and Oracle all moving into China for the BSN networks, okay? And of course, BSN is flowing back into MAS and Thailand and Hong Kong for central bank digital currency type applications. So all this stuff is kind of coming together, right? And at the same time, where does the public chains all fit in? And that's, maybe we'll get to the opportunity to take that one on, but I have a couple of examples.
Yeah. Thank you very much, Peter. I think I can feel your passion oozing out. I think a lot of things are really happening in this space, merging, and in BAS, we talk about convergence of technologies, I think, and there's a global race on this digital health path. I think a lot is going to be driven by the pandemic for blockchain as well. And maybe I'll just move to Paul. Paul, would you like to share something on SMU? I know you have already shared largely about the research, but are there other interesting things on blockchain that SMU is driving?
Okay, yes. I mean, we have a number of things in SMU, both in the blockchain space and the quantum computing space. I'm actually sitting in both areas because I came from decentralized applications kind of many years ago and then got into blockchain. So we have a number of faculty across the schools. Myself, I've been looking at the interoperability of blockchains. We have another faculty who's looking at using data from blockchains and doing analytics, machine learning within the blockchain space. We have a few faculty in the law school who are looking at the legal implications. We've had a conversation particularly around trade finance, there's huge gaps between the current trade finance applications and the trade finance law, which gets very complicated, and I'll leave it up to him. But there's also a lot of interest in the accounting school, so we do a lot of blockchain work for accountants. So yeah, I mean, I think it's really interesting to see how blockchain is being used and discussed, and there's courses, seminars, everything in SMU in blockchain in the IS school as well as the other schools.
Fantastic, fantastic. And I think largely since today's session is on enterprise blockchain, and I think a lot of things are kind of coming together, maybe a general question for the panelists. Do you feel the enterprise blockchain is kind of progressing well, or has it been too slow? And how is it picking up in your view? And I think one most important question is whether quantum computing will have a role, a significant enough role, or is it still far away? Yeah.
Shall I give my view first of all? Mine's the high level view. I don't work for any particular blockchain company. So from my view, what I'm seeing really across all the kind of blockchains that people I speak to is that blockchain is definitely growing in a very big way in sort of niche areas. So there's a couple of people who do guest seminars. One's got a very sophisticated blockchain now on food provenance in India, and it's kind of a niche, but is involving also credit for the farmers as well. It's really kind of helping the sort of the social side of the farmers who are typically kind of underpaid, and they don't really get part of most of what the product is valued at. There's a lot of middlemen. So his blockchain is taking all those out. It's also supplying credit to farmers using satellite imaging and AI to make sure the crops are growing right, and even giving the farmers feedback if it looks like something's going wrong. It's involving banks. It's involving the distribution network. So I mean, I'm seeing that in a number of different areas. That's kind of very niche parts. Then there's a lot of growth. But Thailand as well is another great area, which they've got blockchains. In that IBM blockchain has many companies there now, not on the retail side, but on the intercompany interbank settlement side. But so I think it's not so much maybe the big blockchain projects like the Maersk and IBM that doesn't seem to have taken off, but where there's a sort of a very focused point for blockchain, then I think it's doing very well. On the other question on the quantum computing, I mean, I think there's two angles there. I mean, first of all, what I see is that the quantum technologies do have to evolve. So I think we're looking at a kind of a 5 to 10 year time scale before we can get good quantum computers. I mean, IBM have a roadmap now to have a few hundred qubits within the next couple of years. So I think, and there's many people looking at this every week. There's some new breakthrough in quantum computing in qubits or the network. So I think realistically, we're going to look at 5 to 10 years before we get good quantum computers, and maybe 20 years before we get the quantum internet. But saying that, there's still, I think, areas where quantum computing advantages can be used. So looking at some of the algorithms connected to blockchain. So I think I'd be very interested to talk to blockchain, anyone working in blockchain where they have a particular problem. It may well be that we could use a quantum algorithm to resolve that particular problem. So the whole quantum blockchain isn't going to be around for 10 plus years, but I think quantum computing can certainly be applied, and for what we've seen, it does work. So we can apply it to particular areas of DLTs and particular problems they have. Thanks.
Mm-hmm. Yeah.
I think, look, I'm positively biased here, as you can imagine, right? So I definitely see a lot of good progress and scale coming to in the industry. We have a reasonable share of the market share right now, but there are other players as well, which Peter was highlighting. So we have seen, at least in the last 2 years, financial services companies especially are taking a bit of a lead, as well as the supply chain side taking a lead, right? As Peter was highlighting in some of the use cases. So whether it be banks, exchanges, software companies building for those companies, leading SI companies building for those companies, we see a lot of use cases happening. In just even in our space, we have leading corporates and companies like MasterCard, NASDAQ, DBS Bank here, StanChart, Rio Tinto, Toyota, to just name a few, who are either consuming a solution built on Corda or building on Corda, right, themselves. So look, I'm biased. I see a lot going on here. I think we, as Peter was alluding to, we also have announced a big partnership with IBM and his team, especially to make things easier, right? I think where I see the industry going really is, there are a couple of hot areas. I say financial services will remain a leading adopter and is already one. I think within that space, you will see a lot of action in the tokenization area, or popularly, the digital asset area, right? I think that's heating up. It's been fueled a little bit, I would say, because of the crypto boom right now. So the interest is a lot high because of that. But there are genuine use cases where tokenization is not just bringing efficiency, but allowing companies to create new business models and business offerings. So that's huge. I think supply chain and healthcare will be the other big areas. But then there are, other industries who are leveraging it equally. So whether it be music industry for copyrights, or whether it be, telco industry for sharing of data. I think there are use cases, various industries. So I think, what I feel positive about really is, it's less to me about public blockchains or permission blockchains. It's about, this new technology replacing legacy tech, or many times replacing paper and email. I think I'm fascinated how much work still happens on paper and email, right? I think, so there's a huge, huge opportunity. I think, collectively the industry will really make a difference and really upgrade the infrastructure which is there today. So,
yeah. Tell me about it. I signed a tag of papers on the option to purchase.
Exactly, right? There's no reason that should be the case in today's day and age, right?
All right.
Ernie or Peter, anything to add?
Go ahead, Ernie.
Peter, go. Oh, okay. Yeah, I guess from my point of view, I think we are seeing a lot of convergence, and we are seeing people adapt and change according to needs. And because the cryptocurrency space is booming, gas costs are extremely high. I think that's also pushed a lot of the use cases that to more permission areas. But then if we look at, so one interesting example I feel is the open attestation framework, which was used in Singapore for health certs, right? They had a gas problem because they were using Ethereum, right? And they very quickly turned around their solution. They tap onto Affinity's DID infrastructure, right? And they, using the same kind of public-private key pairs that's on Ethereum, they allow people to sign transactions without sending it to the blockchain, and allowing for verification. So they still tap onto the public part, and they have a private part as well. I think that's where the convergence is going to happen. I see that a lot. I think when it comes to smaller companies wanting to adopt this sort of technology, I think there's also opportunities for newer companies to kind of leapfrog in terms of infrastructure by tapping on blockchain technologies as well, right? So instead of having to set up their own how cloud is helping you to leapfrog in terms of having on-prem servers, blockchain is going to help you leapfrog in terms of other types of infrastructure that you have to originally have to build out internally as well, right? I think that for someone in a startup space like us, we see a lot of opportunities there. We can provide different services to enterprises here that helps them connect, either to consortium blockchains what R3 is doing, and or help them to tap onto even IBM technologies, right? So that's the idea, and I think we will see a lot of that happening in the next couple of years. Yeah.
Mm-hmm. And Peter, a quick one so that later on I can move to some questions. We do have some questions online
okay,
that we can answer.
Okay, I'll be really fast, okay? So I'm going to start with the quantum part, and then I'm going to move back to the other question that you had. All right, so the quantum side, obviously, we've heard a lot about quantum computing and so forth, and the impact. I mean, obviously, the question we always get is, okay, when is it going to break Bitcoin? I know when is the rented capacity of quantum computing going to then target some whale's wallet and just blow up the whole the whole blockchain ecosystem? That's a great question. Actually, some of the experts at IBM have an opinion on that, but I'm not going to offer that here. What I will offer is that those same individuals that build this stuff can also build the defenses against it. IBM has been down selected by NIST for 2 quantum resistant lattice curves, dilithium for key signing and key encapsulation, which is called Kyber. And we have already built these technologies into, well, the stuff that we sell. So if you want your Deducto solution to be quantum safe, come talk to me, Ernie. I can take care of you, man. All right. The other part I was just talking about is maybe a little bit on the business model side. We've talked about public-private and that kind of stuff. But look, if you're a bank, right, and you can give a whopping 0.013% interest on a savings deposit, that's not really moving the needle for me, right? But if you could go ahead and say, maybe I could, offer you 13% on your deposit, right, as passive income, how would I do that? Well, in this case, I would stake on Polkadot, okay? Or maybe I'll stake on Tezos and get 6%. The problem, though, is these banks are regulated and they have to make sure that, people aren't depositing coins from North Korea, right? And then waiting to get the staking rewards and essentially money laundering, right? Or you have a set of banks that have tokenized various assets on a chain. Let's take Tezos, for example, okay? Which is a proof of stake, yeah? And they don't want to worry about having other staking nodes going through an AML process or KYC process. In other words, what they're really looking for in both of these scenarios is give me kind of like the enterprise blockchain consortia, in the sense that all the participants, while it's not trusted, okay, have been at least KYC'd, okay, and they have been, they go through the AML process. In other words, give me private blockchain characteristics on a public blockchain, right? And today, it's becoming possible for a transaction from a financial institution. I'm not going to say one because I'll get in trouble. Let's just say a large financial institution, that has added a transaction on, let's say, the Tezos public blockchain. That entity can go ahead and select for validation another institution, let's say IBM, that is also a validator on that public chain, and we've all been KYC'd. The way this works is this idea of private mempools. So you have, of course, a public mempool for all your transactions, yeah, but you don't know what you're getting there. But if you can create private mempools and all of the staking nodes have been KYC'd, okay, in AML, well then, you know what? That changes the calculus a little bit for public chains, doesn't it? Okay, so if you can then create the opportunity to aggregate and, if you will, route traffic between the public and these private mempools, you get to start the benefit of having public chains provide capabilities of private chains. And I look forward to those kinds of capabilities becoming more and more prevalent. Just like, for example, with Algorand, and they do their clawback on transactions. That's very important from a payments firm's perspective, isn't it? And of course, the speed of Solana and some of these others, you can really start to see, again, those performance, scalability, security characteristics of the traditional private enterprise chain now being brought to the public chain, right? And I think that's, to me, where kind of the future is.
I definitely think that the convergence of these technologies is going to have a lot of parties coming together. So I thank you, Paul, for taking the questions via the chat. So since you have addressed the questions via the chat, with that, 1 second. Oh, there is one more question. So we'll take one question online, and then we'll wrap up with our last question for the panelists. It says, how much to decentralize in an enterprise blockchain? What's practical and what's being adopted? So I guess there was a lot of examples that was given earlier about use case. Then I guess the question would be, how much to decentralize an enterprise blockchain? I think I would presume the question is in dollar and cents. I don't know, is it how much time, or whoever's asked the question may want to clarify whether it's how much time or how much dollars and cents, but maybe we'll kind of address both. But does Amin have any views?
Look, I mean, it depends on the scenario, right? And I don't know if we can comment on dollars or time, but like some scenarios are much better decentralized, right? I think of supply chains. I think those are multiple parties. I think, you know, inherently there is a group of institutions who need to be working on the same transaction or the same flow of goods and exchanging information, right? So those, to me, you know, those are much better decentralized scenarios, right? Versus, you know, if you are the only sole provider of a application of an information, I think that's, and you want to control it, and that's your differentiator versus anybody else, then you'll offer central solutions, right? So I think, to me, I think it clearly depends on, you know, wherever there is multiple parties, I think we feel that, you know, decentralized is the way to go, and that's where the industry is going. If you're just doing something within your own house, I think centralized solutions will fly.
Okay, so given that we have 4 minutes, I think a lot has been shared with regards to not only enterprise blockchain but also crypto, etc. So there are breakthroughs, there are exciting things that's happening. There's COVID driving a lot of new use cases, and of course it comes also with some risk in the adoption. So I'd like to just hear one final question for the panelists, kind of one word on your view about the future of enterprise blockchain. What would that word be? Yeah. Anyone can start once if you have thought about it.
I would say transformative.
Transformative, yeah.
I would say connecting all the companies, finance, people who need it. So to me, we're going to end up with a fully connected world of everything working together smoothly without friction, without boundaries.
Still very positive.
I'll agree with Paul. I think like connectivity will be the key word here. We'll see, we won't see like, you know, one huge blockchain where everyone is on, but, you know, we will see all these different systems using blockchain technology and being able to talk to each other. And I think it is coming. More and more, we see more and more adoption, and we will see more use cases being discovered that has this connectivity kind of element to it as well. Yeah.
I guess I'll just kind of finish it off. From my perspective, the word is easy. Okay, easy in the user experience. If I go to lunch today and I want to pay for it, maybe with a credit card, it's easy, right? As long as I got money, and, you know, I give them the credit card, or, you know, pay law, whatever, it's easy. And that experience ultimately, you know, is where this is all headed. It's not there yet. I mean, if I have to have a MetaMask wallet on my smartphone, okay, you know, that's not for everybody, right? And if I have to manage my own private keys, that's definitely not for everybody. All right. So whilst I would say the technology savvy individuals out there today find working with these different decentralized applications fairly intuitive, the vast majority, however, do not. And so in order to have a future, it needs to be easy.
Definitely. I think your digital health pass, this global race of maybe parties coming together. Well, I just received my first dose of vaccine last week, and I gotten a paper document still, so not a QR code. So looking forward to a lot of people really riding on the pandemic opportunity to make a lot of things happen. So I think we've come to the end of the session. There are some questions that couldn't be taken. You have the details of Paul's email. I think he shared his contact. We'll share it again via LinkedIn so that you can contact either OneConnect or Paul or BAS Association for any questions that we couldn't take in this forum. So at the dot of the hour, thank you very much for a very exciting research sharing, Paul, as well as to the panelists, a very exciting conversation. Thank you.
Thank you. Thanks.
Thank you, everyone.
Ladies and gentlemen, we have come to the end of today's program. Thank you for your attendance. So the report will be sent to you after the event. And for those who are interested to find out more about enterprise blockchain and also blockchain technologies, please feel free to visit the BAS website at www.singaporeblockchain.org and join us as a BAS member or follow us on our LinkedIn. With that, thank you everyone for joining us at this event. Have a nice day ahead, and we hope to see you at our future events again. Thank you and goodbye.
Thank you.